Well, welcome everybody. Today's talk is about bridging the gap between infrastructure as code and GitOps. Infrastructure as code has been around for quite some time. We all kind of have familiarity with it. We have certain workflows that we expect when we're dealing with IaC. And then in comes Kubernetes, which obviously was super exciting and great, super valuable. And then in came GitOps. And GitOps was a new way of doing things. And it's kind of muddied the waters in terms of what you should be doing from an IaC governance standpoint, from a automation standpoint, like how should we be thinking about GitOps and infrastructure as code. So that's kind of the purpose of the talk today. I'm John Dietz. This is my co-founder, Jared Edwards. Jared, say hello.
Hey, everybody.
You got to get real up in there. Yeah.
Hello.
Yeah, all right.
There it is.
So we're the co-founders of Kubefirst. It's a project that we started, I guess like 4 or 5 years ago now. We spent a couple years, nights and weekends, just trying to get the project off the ground. And then we ran an enterprise pilot for a while, about a little over a year. And once we proved that it had the scalability that we wanted, we open sourced it, put it on the CNCF landscape, tried to raise capital. We ended up getting acquired while we were raising capital. Now we got a small team. We're trying to see the rest of the vision through. We've been dealing with Kubernetes forever. We love Kubernetes. In fact, we met each other at our first ever Kubernetes job. I had just finished trying to convince USA Today to not use Kubernetes. That was my stance. It's just another buzzword. I'd seen it 1,000 times before. And then I left USA Today for this new company. CTO said, we're doing Kubernetes come hell or high water. So, and I was the architect, so all right, Kubernetes it is. And I fell in love. I just head over heels. I love the technology. I've been in DevOps forever, and it just made a ton of sense, the framework that they were putting together. So obviously, we've been doing a lot of Kubernetes for the last while, and all that just to say that I think that you can trust our opinions. We've gone through the ringer real deep on infrastructure as code and GitOps. Obviously, every platform's a little bit different. So if you have any questions along the way, please interject. I'm happy to answer any questions or whatever. But we want to start this talk talking about infrastructure as code. It's your powerhouse foundation for your company. There's a lot of stuff that makes a ton of sense to have in infrastructure as code, and to follow your classical infrastructure as code workflows in terms of automation and governance. What I mean by that is obviously you have to start somewhere, and when you're starting to build a platform out, it's important to get that foundation from ground zero, from scratch. You have nothing. GitOps doesn't work very well in that type of an environment because it needs Kubernetes, right? Infrastructure as code is a command line tool, generally speaking, a lot of them are. And you can start from scratch with just some code that you have. And that's really helpful to getting things rolling. And it's super valuable to keep in your IaC workflows certain aspects. IAM secrets, or your secrets management, and the roles and rules around who's allowed to access what. Your foundational infrastructure components you just need in your cloud space. Your VPCs, things like that are nice to have at that root infrastructure as code foundation. However, GitOps lets you fly. It just does. It's an amazing way to orchestrate. we personally use Argo CD as our GitOps engine. It's the one that we're really familiar with. We understand that FluxCD has a very, very good competing product. We've never really dug into it too deeply. But in an Argo CD world, at least, it's a powerful implementation to just be able to put your YAML files in a Git repository and register that Git directory with your cluster, bootstrap it, and you're solving so many different problems by implementing GitOps. Asset management is a tough problem in Kubernetes. You've got all these micro products, you've got all these microservices, different states. You have development teams, generally speaking, that are building apps that need to go to development staging production environments. That dev stage prod delivery methodology requires CI. It requires pipelines to be intact and operational. From a disaster recovery standpoint, that's problematic. You want to have your Kubernetes state declared in such a way that there is no scripting needed in order to reproduce the exact same environment. And if you have pipelines, your developers have been working, they don't know that you're in the middle of an operation, or you can't even plan certain operations. If your production cluster just disappears in the middle of the night, you've got a problem on your hands. And so being able to establish what your desired state is in a declarative way, in a Git repository, in a way where even if a cluster were to disappear, it would just come right back. That's an amazing new capability that GitOps truly delivers on. It is a viable implementation. And with Kubernetes now extending, with CRDs, the ability to really manage anything that you want in Kubernetes, you're no longer limited to using Kubernetes as an application host. You can now use it as an IaC host as well. And that sort of opens up all these different new avenues about the right ways and the wrong ways under different circumstances to run your infrastructure as code automation. Platform engineering is the latest evolution in Kubernetes. We all know that it's a complicated, complex technology, and with the expansion of cloud native doing what it's been doing for the last 5 years, there's just a ton of domain knowledge that you have to know to just be able to run your infra. And platform engineering teams are largely trying to reduce that cognitive load on the development teams so that some different owner can own a platform as a product and deliver it to the software teams within that organization. And buying into GitOps and allowing it to build your cloud resources out for day one provisioning operations is really, really powerful, but you still depend on infrastructure as code in a GitOps environment to establish that foundation and to wake up your GitOps engine. And our opinion is that you should basically get into GitOps as fast as you can and try to stay in GitOps once you transition that platform control from your IaC core foundation over to your GitOps. And then you have a decision to make later, and we'll get into those details about whether or not you should allow GitOps to govern your resources, or if you should perhaps transition that to a different workflow. So day one orchestration is a really big deal with GitOps. You have this new methodology for delivering infrastructure, application code, et cetera, where you can just have a directory full of everything, full of Nginx and Cert Manager and external DNS and Vault and something to run Terraform and whatever else. You could have all this content on your platform, all these micro products, and you need to be able to reproduce the delivery of that platform in that cluster, which is a tough job to do. A lot of companies have lengthy run lists and a whole bunch of notes about, oh, don't forget to do this, don't forget to do that. You can get rid of all of it with GitOps. 100% of it, you can have the state of your Git repository capable, without any scripting, of reprovisioning complete environments, which is bananas. It's really cool. So let's explore some of these IaC tools together. Jared, do you want to come in here and take a few slides?
Yeah.
Take a break.
So here we've got a few of the more popular ones, we should say. So we have Terraform, OpenTF, which is obviously new and up and coming, considering the HashiCorp deals lately. And then we have Pulumi. These run as command line tools. We also call out OpenCP, which is a project that Sivo is putting together for another way to manage infrastructure. Basically, they're trying to put a shim layer between their cloud API that allows you to use YAML to create their resources, which is pretty cool. It's still a little bit early, but we're definitely going to keep our eyes on that one. Then you have Crossplane and Atlantis, which are more of the control plane. So you have to have Kubernetes to use those tools. Atlantis is just a wrapper that runs Terraform workflows for you, but it's nice that it gives you a really nice audit trail, but also gets to run in your cluster. So that story, for anyone who's run Terraform, where you maybe have a failed apply from another developer on your team and the state's in a little bit of a weird state, those things are eliminated largely by using something like Atlantis that gives your whole team a central place to manage that same infrastructure as code. What's the difference between IaC and GitOps workflows? So with Atlantis, you can see there's a feature branch, and then there's a plan. Then there has to be a human intervention to review that plan, and then there's a human action to apply that. It gets merged automatically by Atlantis to the main branch after that. And the opposite is for Crossplane, which is that you have your feature branch and you get to do a review of that YAML spec that you're going to be pull requesting, but it goes directly to the main branch. And then when you're running the Terraform provider in Crossplane, you miss out on that opportunity to review a plan. It just immediately starts applying. So here we are. Which one is better?
Which one is better? Anybody have any opinions? GitOps workflows, IaC workflows. Maybe you're running Terraform in a pipeline, right? There's a lot of companies running Terraform in pipelines when they hit the main branch or when a pull request is open. Anybody have experience with either workflow, or think you have a preference one or the other? What do you think?
It's not correct. Funnily enough, I was at a talk yesterday where people were talking about Crossplane, but someone brought up that they don't have the confidence to move to something like Crossplane because it's like, okay, this is the state, you're telling me to do this, okay, I trust you, I'm going to try and do it, right? And then they'll probably get into an erroring state if they can't. They want that plan, they want that step to because it makes them feel confident, it makes them
right.
Just that extra check makes them feel more assured about what they've just done.
Well, I would ask the rest of you your opinions, but that was the perfect answer for the next slide. And there's no way we're asking it. No, just kidding. By all means, if you guys want to jump in. But yeah, no, the comment there just for the camera is that, one of our audience members was in a talk yesterday. They were describing a scenario in GitOps where they didn't have full level of confidence with the Crossplane type of workflow because you make a change and it just applies and there's no opportunity to get that human inspection of the plan and what it's doing. So if Crossplane decides that it's time for your production cluster to disappear, it's going to disappear. And that's problematic, obviously. So you want to bring up the next slide?
Yeah. So for your infrastructure as code workflows, it's really helpful for your foundational cloud resources, production clusters, security clusters, anything that you want to have that extra protection on. Users know IDC, Git repository configurations, secret access rules, and ACLs, things of that nature.
Yep.
For GitOps, there's definitely a good use case for something like Crossplane that doesn't need as much of that governance for ephemeral environments, virtual clusters, CI environments, ETL clusters, machine learning platforms, day one, day two provisioning operations and pre-production environments.
Yeah, and this is kind of like the tricky bit is knowing, because there are times where you're absolutely not, it's not a good idea to allow GitOps to just destroy stuff that you care about. So you have to identify what the things are that you care about. And it's different from shop to shop, but generally speaking, you know, there's a pretty decent list there. It's like, it's your security stuff, it's your observability stuff, it's production, it's IAM, it's who can access the system and who can access secrets. And if you can get all of that stuff in an Atlantis style workflow, where there's a human inspection, then that's super valuable long-term for day 2. But that doesn't necessarily mean that that's how it had to be created for day 1. Day 1 operations can include a full provisioning, all using Crossplane to create that infrastructure, and then we're capable of taking that Crossplane provisioned content and transition the state of it over to Atlantis so that Atlantis now owns it, and you've shifted your governance from a GitOps-oriented, fast machine, just create everything, please, and then at the end of provisioning, at the end of day 1, you just you orphan it from Crossplane, shift it into Atlantis, and now Atlantis is governing it from that point forward, or until you change your mind and you want to go back to a GitOps workflow, which you're free to do as well. So it's kind of a crazy concept. If you're getting into platform engineering, you're going to be building a lot of clusters. You're going to be provisioning a lot of stuff on a lot of clusters all the time. We tend to think that it's best for that layer to include your IaC layer, like we build from scratch all the time. And leveraging GitOps for that provisioning is better. It's less scripting, it's less runbooks, it's less notes, it's less breakable stuff, less risk of drift. GitOps is amazing. It's just not always what you want for your permanent IaC automation stance due to the governance that you need on your very important cloud resources. So, did you know, Jared?
Well, I think you.
What did we know? Did I just cover all
you
of
just
that?
you just covered the slide. Yeah. That's all right. I think.
So yeah, I think it's demo time.
Yep.
Yeah, so we're going to do some demos. So full disclosure, we have no idea how well this is going to go. It's been a rough day. But we love live demos. We think our audience always deserves live demos. We're going to be as honest about all of it as we can. No tricks up our sleeves. Let's figure out what works and what doesn't work with Crossplane and Atlantis today. What do you guys say? All right. So, yeah, let me talk you through what we're trying to do. We're going to start out with, let's create a new cluster called production using GitOps.
All right. So,
do you want me to talk while you're clicking through?
that would be helpful.
Yeah, so this screen right here, this is our product. This isn't a product pitch. It's just an easy way to get a cluster created. If you ever wanted to use our product, it's open source. It's completely free. It's incredible. It provisions clusters in on the Civo cloud, it's like 8 minutes, and you get everything. Automated IaC, GitOps, Terraform managed in Atlantis, Crossplane, application delivery. We build containers, build Helm charts. We do, like, you name it. It's an enterprise with a single button. All you have to do is give us your Git provider, your cloud provider, and what domain you want to attach it to, and we're done. And then we take this GitOps template, we hydrate it with the details that you give us, we give it right back to you as your GitOps repository, so if you don't like our opinions, you get to change it, take it any direction you want to go. It's a super cool project. And we have 250 engineers in our community now that are all using the same products the same way. So if that's valuable to you, it's why we built the company. It would have been so valuable to us. So we hope that it's helpful to you. But anyway, that was just a quick show of creating a cluster. And
Yeah, all my browser tabs are just spinning, so I don't know what to do.
all your browser tabs are just spinning.
Yeah, that's not going to be good enough.
Here, we're finally going to create a Kubernetes cluster in the Civo cloud.
That's the story.
That's the story.
But that one showed up in our list here, and it's provisioning, so that's great news.
That is
let's
great
do
news.
Kubernetes.com. get lucky. Let's get the out that. Let's go to our registry is kicking off here. All right, take it away.
All right, so yeah, what we're looking at here, this is an example of a GitOps day one provisioning operation. This is a cluster that we're creating. Jared, would you mind going to GitHub, to Kubernetes, and just showing them the commit that just happened when Kubefirst created that cluster so they can understand like what woke up Argo CD? All right, so here we can see that we have a registry, and then within the registry, we have this new production folder that we've created that has all of the apps that we want in any cluster that we create. Now, every company is going to have different apps that are important to put in all of their clusters. But these are things like, obviously you've got your foundational tools, you've got Ingress Nginx and Cert Manager and external DNS and stuff like that. Maybe you have some observability tools like Datadog agents or New Relic or whatever, and you just kind of drop all this stuff in a single directory, and you can organize, and we have examples of like how to have it all organized so that it flows this way. Right now what you can see is we've got these two sync waves, one of which is complete to create the provider config. We have one running right now. That's GitOps that's running Crossplane right there. So, but it's Crossplane that's running Terraform code, which is weird to say because most people think that Crossplane and Terraform are competitors, which is reasonable. But there also is, just to muddy the waters further, a Terraform provider in Crossplane. So you can run Terraform in Crossplane. It's kind of a messy little universe in this GitOps IaC space. But anyway, so that provisioning operation, Jared, if you bring up the Civo Cloud, we can see that production. Did it just finish?
Yep.
Fantastic. So that cluster is going to provision, and then once Crossplane agrees that that operation is fully complete and synced, then we're allowed to move on to the next application, which in our case is going to be probably Ingress Nginx first, and then Cert Manager, and then external DNS, and we kind of go down the list of all the different apps that we want. When you're tending to the order of operations, in Argo CD, there are, in fact, we just finished a talk a little bit ago, if you catch the recording of it. There's all these chicken and egg scenarios that happen when you're doing cluster provisioning from scratch. Things like, you want all your secrets to be in a secret manager, but you're creating a management cluster that's going to have that secret engine in it, like HashiCorp Vault or something. And so, like, where do you put your secrets when you want them in something that doesn't exist yet? And there's all these messy scenarios like that. So if you get a chance to watch that, you'll get a real good deep dive on the orchestration of these pieces. But this is really where the power of GitOps-oriented IaC comes into play. It's just being able to say in a simple, stateful way, I want this stuff in my cluster. I want it to happen in this order. And as long as that's always the way that you're getting your infrastructure, then you're always practicing, you're always getting your disaster recovery motion built in. Now this thing is probably about what would you say, 75, 80% done here?
Yeah.
Yeah, so
20 more seconds.
So we've got a brand new production cluster. We've got almost all the tools that we want in a production cluster. Yeah, it looks like we've got all the tools that we want in the production cluster now. And what are we going to do next? I don't remember.
Are we importing to Atlantis?
Yeah. Let's do that. In fact, can we show a quick example of just an Atlantis plan that creates a secret and then a Crossplane orchestrated implementation of us? Or we just saw GitOps, so we don't have to see GitOps again. But if you could show us the Atlantis workflow, I think that would be helpful to sort of understand the two before we get too much deeper. I would like to take this moment to remind everybody that Jared's not on his laptop right now. So if you see him struggling, it's all my fault, I think. I don't know. I didn't mean to do it to him. It's just kind of the way the cards were dealt today. So here Jared's going to, this is the repository that we give you when you do a Kubefirst install. It's the one that we're the most familiar with, so that's why we're doing our demo on top of it. But what we're doing right here is just creating a new Terraform file in a directory that's already managed by Atlantis when you do a Kubefirst provisioning operation. So if you just add stuff to these pre-existing directories, then automation's going to wake up and run plans for you. It's going to, if it's a pull request, it's going to show that plan in your pull request and show you that sort of human element that the Atlantis ecosystem brings to the table. You're on a branch?
I am.
Yeah, good.
Was. Oops. You don't have
that line
Yep.
3 times. Yeah, there you go. One of these days I'll fix that, Jared.
I know.
You haven't been after me for enough years on that one.
All right, so let's create this pull request.
So yeah, so Jared basically just created a pull request against our GitOps Git repository in a Terraform directory that's being managed by Atlantis. And as a result, when he puts a pull request forward, Atlantis is just going to wake up. Are we good?
Yeah.
Okay. Atlantis is just going to wake up, run a plan on the user's behalf, post that plan in the pull request directly. If you do a hard refresh, you might get it.
Terraform Vault New Secret. Man, live demos are not going well today. There it is.
All right. Can you expand that guy? Yeah,
Yep.
thank you. So this is the human element of an IaC workflow. This is that governance that people are talking about when they say they don't like Crossplane. You have this opportunity to say, hey, something's about to change. Would you like this thing that's changing? It'll show you if it's going to delete something, what it's going to delete. If it's going to create something, it'll show you what it's going to create. And if it's just going to edit something in place, it'll tell you that too. And if it's a destructive edit, it will tell you that as well. So like if it says, you know, hey, we're going to create a new production cluster by destroying production and recreating a new production cluster, you get that opportunity to see that firsthand, which is why it's really great for prod, security, IAM, secrets, stuff like that. And we already just saw the opposite of that, which is GitOps, which is like just put what you want in main, and Argo CD, the way we have Argo CD organized, Argo CD is just watching the registry always. So anything that changes in the registry becomes real. Now, for day one provisioning operations, that's super handy because then you can just organize everything in desired state that you want permanently, and it becomes real, which is exactly what you want when you're building. But if you're building a production cluster like we just did, you might not want that to be under the responsibility of Crossplane long term. So Jared, can we show orphaning the resource, the production cluster? Well, in fact, before we do that, do we want to go through with trying to destroy production and see that whole workflow? This is the real dicey part.
Let's see.
So we're in the Civo cloud here. This is a resource that's currently managed by Crossplane and Argo CD GitOps. We're just going to go to the cloud like some new employee that we just hired, and we're just going to delete the production cluster and hope for the best.
And we did, so we're just waiting. We have our Crossplane provider set up to run on a 2-minute poll, so we're at the mercy of about 2 minutes. It could be 60 seconds, could be 20, don't know, but hopefully very, very soon.
And it's at this time that we would like to thank our sponsors. Let's hear it for the Civo Cloud. Yeah, we love Civo Cloud. We love, here we got a production cluster coming back. That's exciting. So Now, this is kind of new stuff to us. We're literally running off a main branch that got commits about like 16 minutes ago, so it's not polished yet. I wouldn't necessarily recommend hopping into your Civo cloud and deleting your production cluster today on the Kubefirst platform, but it is the direction that we're going with everything, where you can not only have self-healing infrastructure, but by combining infrastructure as code with GitOps, you're able to self-heal at the cluster layer. Everybody's familiar with Kubernetes and self-healing at the application layer because of the nature of the way that Kubernetes works, where the node is not really that important. But it goes further with GitOps, where you can extend that same concept all the way to the cluster itself, destroy it off the face of the earth, and as long as there's Argo CD in a management space that stays safe, then that production cluster is just going to come back, and then because of the way that we have, so with our GitOps story, because of the way we have all the applications registered to hook the directory into that new cluster, as soon as the cluster is available, the orchestration continues and delivers all of the applications to that infrastructure. So you not only get your cluster back that you just destroyed, but you also get all of the applications that were in that cluster at the exact state that they were in when he hit that delete button, which is super powerful. It's like, if you're in the DevOps world at all, like that's the holy grail that we've been searching for so long. Like scriptless, there's no script, he's not running any scripts over there. We just hit delete and we're just waiting for Argo CD and Crossplane and all of the orchestration that we have in that GitOps repository to unfurl and create your platform, and then you can even lay your applications on top of that platform, and you have, like, if high nines is really important to you, that's super tempting. But you don't have to stay in that state either. Yeah, you have a question? It's a really good question. So the question is, how is it able to do that? The way Argo CD works is you can register Argo CD against a Git repository. First, you have to say what repository you want Argo CD to look at, and then once it's able to connect to that Git repository, you can tell it a bunch of things. You can tell it that you want to install a Helm chart. You can tell it that you want to just apply a Kubernetes manifest. But one of the most powerful things about Argo CD is the ability to say, I would like to have an app of apps. Now, an app of apps is kind of a vague concept, and it goes further than just two generations. Think about an app of apps like, I have an app called Production. Now, that's not really an app. There's a whole bunch of different microservices that go into production. Maybe there's databases and stuff like that. So you can create an app of apps, and those of apps are all of those different microservices that you deliver to production. And you can unfurl that further and have an app of apps, and you can just go GitOps crazy with it. So when we delete that cluster, we have Argo CD looking at a directory for its desired state that it's supposed to enforce. And it wakes up and it says, hey, I'm supposed to, because one of our first sync waves is Crossplane, and it's supposed to be running some Terraform, and there's already a desired state in the Git repository. There's a Terraform state in an S3 bucket, and there's no cluster. So we think we're supposed to be managing a cluster. There's no cluster there. Terraform's going to do what it does naturally when it creates a plan and say, if you want me to, I'll create this cluster again. And because it's Crossplane instead of Atlantis, it doesn't ask for a human's permission. It just creates what it's going to create every time. So does that answer your question well enough? Yeah? What do you got?
If you want this, let's say there's a change to production, we roll it out, and they come back and say, it's wrong, step back. How does that step back conversion work? Is it just look at a state file, previous version of the...
Yeah, so it's truly all Git. So your Git, at least the way we have our GitOps organized, our opinion is that main branch is always king, and whatever is on the main branch is the desired state across the entire organization. And you can break that out into different registry points for different teams or however you want to do it. Don't recommend doing like a develop branch or anything like that because it makes it cloudy what the desired state actually is in weird ways. And promotion of environments in a GitOps way, it's just kind of messy when you get into the branches. When you start to get into it in a real sense with real applications, it just gets messy when you try to promote from pre-production to production or whatever. So. That's all you do. Yeah, you go to your pull request and revert, and it's always forward the way we use GitOps. We always, if you implement something and it breaks something, then your next change is not to roll anything back. We never look back. We're always reverting the commit forward, and that new forward state that's now on main is now the new version that's going to become in production, even if it was the same version from 2 revisions ago, right? Great questions. Thank you, guys. So how are we looking over here?
You got so many tabs.
It's set them up to fail so bad.
I love it. So looking at my laptop.
I just don't know what happened to the other window I wanted.
I'm surprised there's not like 95 tabs across my Chrome browser. I think I had a moment of needing sanity earlier today and had to close everything out, so at least we got that going for us.
One time I got mine to the point where it wouldn't like render any new ones properly because there were so many.
Is that a fact?
Yeah. It was like over 100.
Yeah, once I have about 50, I just open a new Chrome.
It couldn't load them properly on the screen because there was so many.
That's fantastic. So we're almost synced. Are we full?
I think we're in good state. I added a new cluster that, actually, no, this is still registry production. So this is the Ingress Nginx problem.
Oh, yeah, so we do know about one problem. This is known, this isn't us going off script or anything. When we destroy a cluster and the infrastructure comes back, and then we start putting all the applications back in, for some reason, Nginx is troubling. It gets in this weird state where it thinks... Jared, do you have a good explanation of what Nginx is freaking out about?
When Nginx installs initially, it creates some secret that's added to the cluster, and it's like a pre-hooked job that runs. So when the state is still like the same instance of Ingress Nginx in the new cluster, that secret doesn't exist from the old cluster because the job ran before Ingress Nginx was installed. We could probably fix that by putting like a replace statement on the Ingress Nginx application kind, and then it would just force a full reboot of that. But we, as he said, 16 minutes ago, we didn't have time to do that. So.
Yeah.
It's a little more than 16 now, but anyways.
So in any event, at this point when we're in this state, the resolution to this problem, which is truly the resolution to a scary number of problems, is to just go to Argo CD and delete it and then allow it to come back according to its desired state. And then whatever it had in its memory or in its cache or in its whatever Redis or whatever the problem was, you just obliterate it off the face of the earth and then it comes right back in its mint condition. And we hope that's going to be the case right here. I think if you...
Yeah, so this is the pre-hook job that I was mentioning that did not run in the new cluster after it was deleted. So a couple more things to automate there.
In Azure with Terraform, quite a few things work like that.
Is that right?
Yeah, you gotta throw it away before
I'm curious, with the Atlantis workflow, is it possible to do something where when we add new elements, I want approval, but if someone decides to be a mad person going to the CV dashboard and just nuke a resource, is it constantly reconciling that, or would you have to rerun a plan?
You always have to rerun a plan on Atlantis, and that's the tricky bit. So like, for example, if this resource was not managed by GitOps when we destroyed that cluster, and instead we had orphaned it from Crossplane and shifted the responsibility over to Atlantis, when we hit that cluster, if we were to run a plan somewhere, it would know that there's a missing cluster and it needs to create a cluster. But that's not happening until there's some proactive action. Now, it's pretty easy to set up some hacky little things to make triggering a pull request super easy. The rule with Atlantis is it's watching different directories that you register. Can you bring up the Atlantis YAML real quick, just as a
Whoops, yep.
quick visual?
Sorry.
So there's this Atlantis YAML that just sits in your GitOps repository root, and it lays out all the directories in Terraform that it's going to manage. And whenever you hit one of the conditions, it's just saying, hey, we're going to watch Terraform Sivo, and any .tf file or any tf state file or any type of file like that. Whenever any of those change in a pull request, we're going to run a plan. That's how Atlantis works. So at this point, Jared, do you want to take that cluster? Oh, anyway, I didn't finish the story. So had that been managed by Atlantis when we deleted it, nothing would happen. But if you trigger a plan, and submit a pull request that even a white space change in any of those TF files is sufficient. But if you change, and a lot of people just do trigger.tf, and so that you can just kind of dismiss it when you see it in the pull request. But when you submit that pull request, that's when Terraform's going to wake up and say, hey, would you like your cluster back? You type Atlantis apply, and it's automatically going to create it for you. If it's successful creating it, it's going to automatically merge your pull request, merge it with the main branch, and then you're back to your good state. And then if you have, you can still have all the power of GitOps, even with Atlantis managed clusters. So for example, it would run a plan and just be like, hey, I need a new cluster. Can we create a cluster here? You say yes, it's going to create the cluster. But then because of the way we've stitched GitOps to the registration of that cluster, it's also going to get all of its applications, and the Argo CD GitOps engine wakes up and says, hey, we have a cluster here, and this cluster is supposed to have some Kubernetes stuff in it, and it's completely empty, so let's load it up with all this stuff. So you still get all that power of GitOps, even though it's being governed by Atlantis to protect your production cluster. Does that make sense? Awesome.
Just one question. I've seen, in tools do similar sort of things. Like what I've seen happen is versions of things will get out there or whatever, and then stop working with each other. Is that something that you can run into in terms of re-provisioning all of those things when get dependency changes or something like that?
Yeah, the reality of it is that it's muscle work. It's hard work. You have to roll up your sleeves. It does get dicey. We always try, whenever we have those situations, we always try to dig into the root cause and why was there a collision? Is there something about our naming convention that we could do better so that if it were to recreate, it wouldn't collide, or whatever the problem is, you kind of can get down to the science of why it was a problem and shift around conventions typically so that you can avoid those circumstances. Or maybe it's not a convention-based thing where you're colliding with a resource. Maybe it's just some new scripting when it's generation 2 that you have to include in your GitOps in a idempotent way so that it works. It basically just jumps right over it if it's your day one provisioning. But then if it's a recreation scenario, then it can invoke itself and just kind of unfurl, and that just becomes a part of your cluster's desired state in GitOps. So you just kind of have all of those rules laid out in a clear way so that, if you build this great system and it's fully automated, and then you leave and go on to work at some cloud or something, and then the next guy comes in or girl comes in and they're responsible for this platform that they didn't build, you get to walk that full chain of your desired state right from the central registration point. And we've literally hired people that in very, very complex organizations with tons of microservices, and you can hire a good GitOps engineer to come in, and if they're familiar with your app of apps pattern, if you're an app of apps team or whatever, they can understand everything about production on day 0. It's incredible how easy it is to grok the way the system works and understand all the different services that you're delivering and all the namespaces and everything, and you can just kind of figure out what you care about and walk the tree and just kind of go through Argo CD and see how it's all organized, and it's a really nice way to run production. So what do we got here? What's this?
So that basically just took all the Terraform that was in Crossplane, pulled it into an actual Terraform file, registered that entry point with Atlantis and the Atlantis YAML, like we mentioned a few minutes ago. Also made sure, I forgot the first time, but if anyone was watching, you can add a deletion policy to the Crossplane resources to orphan. So now Crossplane is not going to actually delete that resource when I pull request it away from the system. It's just going to abandon it, leave the actual cloud resources behind it available. And because we've already run this Terraform through Crossplane, Atlantis is waking up and saying, there's no changes for me here. I've already got the state already matches the desired state or the declared state in the Terraform. And so now we can just Atlantis apply this. Nothing is going to change about the system. The resource is just no longer managed by Crossplane. It's managed by Terraform. So you can still provision your clusters quickly without those extra steps. And then if you have some that you want to make more important that you want to keep around or have that governance on, you can just transfer it into Atlantis with really no effort. So
Right on. Can we see an example of the files that you changed?
Yep.
So let's see. Yeah, I guess that's the new directory to manage production in Atlantis. This is the deletion policy to orphan in Crossplane. And then down here, this is just good old-fashioned Terraform, and we stole it out of where we had it in Crossplane and just copied it over. And did we have to edit it at all, Jared? No. Just the lock, stock, and barrel just copied over.
Yep.
So it's natural Terraform. It's being managed by Crossplane and or Atlantis, and you get the same automation, but with different layers of governance was really the point of what we were trying to show. Now, you don't have to run Terraform in Crossplane. I want to be clear about that. Crossplane is an IaC technology, and they have their own native resources. They have their own marketplace of providers in much the same way HashiCorp does. Now, there's some differences about it. Some things that we'll mention Crossplane doesn't today seem to have the same level of support of the different resources that you need to do IaC. Terraform has been around the block. They are the industry standard, and we'll see how long that lasts with their latest BSL decision, but you don't have to use Terraform. What we just showed you here, though, you do. Taking Crossplane and leveraging it for GitOps day one provisioning, that you can always do that with Crossplane, whether you're using Terraform Crossplane or native Crossplane provider resources. But if you have an interest in moving that into a high governance type of space like Atlantis provides, Atlantis only works with Terraform. It doesn't work with Crossplane. It doesn't work with Pulumi or anything else. It's just a Terraform workflow automation engine. So if that's really valuable to you, then leveraging Terraform in your Crossplane might also be valuable to you so that you can take advantage of the GitOps provisioning operations like you saw here today. So wanted to make sure that was clear. Yeah, I guess, how are we doing on time? We got
4:55.
just enough time for one last pitch. So my buddy Jared and I worked our tails off to try and create this instant platform. One of the hardest things about building a project in the Kubernetes space is just getting the information out that the technology exists. And above all else, that's what's most important to us. So we hope you try it out. We support 6 different clouds. We have a local variation of the platform. We support GitHub and GitLab flavors of Git providers, IaC, automation, Crossplane like this, Terraform, Atlantis. We have secrets management in HashiCorp Vault right now. We have, we do application delivery. We do all the different things. So check it out. We have this cool community, and we hope that you'll consider joining us. So thank you, guys.
Thank you.